Hello, everybody. I am super proud to introduce my good friend from Belgium, Mr. Ameye. And today he's going to be talking about the value of integrating ruler and MPC testing. It doesn't matter for all your oil monitoring programs. And just so you know, the code for this session is right there. So play to win there. And then, I know you've got to run at the end of this. So I'm going to let you share your screen and get on.
Okay, thank you very much, Josh. Thank you for your introduction. Good morning, ladies and gentlemen. Welcome to this session of LRVS. I am sure you're all enjoying this second edition of LRVS and learning a lot. So today in this session, I will let's say take a little bit of a helicopter view on these methods, oil analysis methods for your oil monitoring programs. And it's important that first we have a look at the function of antioxidants, how monitoring antioxidants and an MPC method can be complementary, can be really of high value. Um, some of the latest needs that we see as part of condition monitoring programs, which will fulfilled by a ruler and MPC. We'll also talk about how OEMs and standard test bodies are approaching it. And last but not least, I've selected for you a few applications, and in 25 minutes we should be finished. So besides the phenomena of wear, which you have heard yesterday, a few presentations about, oxidation is a top nemesis, I would say, for lubricating oils. And like we say, virtually all lubricants experience oxidation, even during storage in their drums. And just for your memory, oxidation, it's a chemical reaction accelerated by heat. Certain contaminants, think about iron, copper as catalyst. As it will, of course, reduce the lifetime. Every 10 degrees C increase of lubricant will, in fact, reducing the lifetime by 50%. It impacts reliability. Think about the consequences of oxidation being deposits, oxidation products, and of course, like we heard this morning in the sustainability panel, we all want to make the maximum out of lubricants. So controlling oxidation is an important part. Very often visuals are better than words. So here we see um, an example of extreme oxidation. Yes, as in some of my first courses of chemistry, I learned that polymerization due to oxidation is a typical example. Of course, don't let your fluid go in that stage, especially. So to visualize it, and my colleague Greg made this fantastic visual. And antioxidants, you need to see this like an apple's skin. What is inside of the apple has to be protected, and it's protected by the skin. Well, it's exactly the same anomaly with lubricants. The inside of the lubricant is being protected by the antioxidants. And of course, it's up to you to decide what state you want to see your lubricant. I know what condition I will take. I prefer a condition, of course, like this. And antioxidants can be divided in different classes, so primary, secondary antioxidants. And I wanted to really include this slide because I think it's, I get this question so often, what is oxidation and why do antioxidants intervene? Well, in this graph, let's just start here where you have the initiation phase. This is your hydrocarbon chain. It will react with oxygen. It will produce these free radicals, very active components. And these free radicals, if you don't stop them, they are going to have like a chain reaction, and you continuously propagate and you make free radicals. And then, of course, what will happen is that antioxidants here play a major role. They will stop this chain. It's called the chain breaking reaction. And so you will then produce some peroxides, and the peroxides will then be possibly decomposed by secondary antioxidants like zinc dithiophosphate. So the primary antioxidants are the ones who are interacting here mostly and as a radical catcher. So let's take a little bit of a helicopter view over 100 years of oxidation testing. In the late 1800s, mostly mild oxidation, acid number was used, viscosity, not much changed until mid 1900s with the upcoming installation of steam turbines, coal industry becoming very important. And then for oxidation performance testing, RPVOT was used and introduced even a TOST D943, a turbine oxidation stability test, and in some cases pressurized digital scanning calorimetry. These methods were all having their great value, and with the appearance of new group base oils as well, gas turbines, the individual antioxidants measurement became imminent. And this is then the two methods covered by voltammetry, LSV, as well infrared. So let's take a view at LSV. For those under you probably know it better as a ruler. Ruler stands for Remaining Useful Life Evaluation Routine, a technology developed in the mid-90s. Meanwhile, its test method standardized and are part of different ASTM DIN standards. Basically, what we do with this method is you're going to follow the depletion of the individual antioxidants in the lubricant by comparing fresh oil, which is here the green line, the green graph. You will then see the depletion of your antioxidants over the time, and it helps you to individually monitor. In this case, you can monitor aminic antioxidants versus phenolic antioxidants at the second peak, helping you to understand and predict, and that's very important, predict the lifetime of a lubricant. LSV, linear sleep voltammetry, it's like a voltage scan which you will perform. It's electrochemistry, and you're going to measure the functional group of the antioxidants, its reaction by oxidation, and every oxidation wave peak that you can see here represents one specific type of antioxidant. For example, could be a zinc dithiophosphate or more aminic antioxidants, phenolic type of antioxidants, and you can see that the time let us know the type of antioxidants where the area or the intensity, the peak intensity, tells you about the remaining quality of the oil antioxidant. Antioxidants are available in a wide range of chemistries, and therefore LSV applies different electrolytic test solutions where you can then also measure a different type of antioxidants from amine phenols, for example, in a turbine oil, or if you want to measure more phenols in hydraulic oils, or if you have more ZDP aminic mixtures for combustion applications. We'll come back on that later and with some specific graphs, but it's important to apply the right test solution in order to detect the individual antioxidants. LSV is a method that is then largely implemented from 2000, and by the mid of 2000, let's say 2004, 2005, there have been a large change in the use of type of base oils from group 2 to group 3 base oils. Just as an answer of extending lifetime of fluids, and at the same time with this implementation, we noticed it was important to understand the oxidative degradation LSV. At the same time, understand the contamination buildup. What are these degradation products? How will they behave in these hydrotreated group 2 and group 3 base oils? To give you a specific example, this is an extract of paper presented by Livingstone, Thompson, Okazaki at the ACM Turbine Oil Symposium, where in 2005, where you could see that over these 8 cycles of oxidation with different range of oils, that aminic antioxidants show like a gradual depletion remaining at 90%, whereas phenolic antioxidants have a constant depletion until less than 20%. And irreversibly, you can see how MPC, as a test method, which I will explain in a few minutes, measuring these soft varnish degradation products, is irreversibly increasing. From there, it was clear that it was going to be important to understand the production, the presence of these soft degradation products in the fluid. And the method was, I would say, by 2007, 2008, developed and standardized by 2012. As part of D7843, and measuring the amount of oil degradation products in fluids. It's I would say a test method which is using specifically the 50 milliliter of oil, 50 milliliter of a solvent. You bring them in together. You try to then extract the insoluble components over a patch membrane by vacuum filtration, and then you will produce a typical patch. The patch, as you can see, I made here a few selection with different colors, different UV color intensity. The color intensity measured in the spectrum of the visible spectrum of the light between 400 and 700 nanometers will give us a typical value of a delta E. Delta E, or if you want, it's the enthalpy, basically the change in the color light absorbance. And you can see that the darker the patch becomes, with limits of 20, 25, we will then come into levels where you have higher concentration of the soft contaminants. Not only the color, the intensity is here important. And not to be confused with the oil color. I take here an example, which I would like to thank our partners from Ocean Team Qatar for this picture, where you can see on the left side an oil really dark and an oil on the right side quite light. And if we compare the MPC patches, quite remarkably, and we see that the MPC patch of the lighter oil is much higher than on the dark oil. So never really judge an oil condition by its color, because it will not be correct. Antioxidants then by LSV will show here over this trend of oxidation test a nice trend of depletion between different weeks of thermal stress. And when we then look at the individual antioxidants, we can see that here some of the type of aminic antioxidants deplete differently versus another type of aminic antioxidant. And that has also then a relationship with the MPC. We can see that the sample between 2 and 3 makes a difference, just because this type of aminic antioxidants has depleted faster than, or it totally consumed, in fact, because it's not there anymore, versus this diamine, which remains longer, but then has not the ability to keep the soft contaminants in solution. I also want to really emphasize that varnish tendencies And MPC analysis is so important to also enable to understand difference of performance of turbine oils in function of its equipment. Here we see, for example, two different gas turbines, and we can clearly see that on these gas turbines we see different levels of production of MPC. Just because of operating conditions and the type of equipment. Talking about then the needs that we have seen as an evolution today into the market, and I would say over the last 10 years, there has been a tremendous change and need. Um, as we have seen yesterday in the panel on condition monitoring, it's clear that there's more evolution in methods to be expected, but why would be then methods like LSV, ruler, and MPC becoming important? Just because today condition monitoring programs have high requirements, and if you can bring value by being able to monitor lubricant failure, then in a proactive way, that is of very high value. It will make your condition monitoring program so much more of high investment, return on investment. So contamination, well, it's well understood. Think about isoparticle counting. I don't have to explain that. ICP, ferrography. Oil degradation as a second parameter as part of the monitoring of lubricant failure. MPC will be part of that and will complement especially ultracentrifuge, FTIR, gravimetric analysis. And the third part, understanding apologize, lubricant failure, is then the individual antioxidant depletion. If you can monitor these and these three parameters, in addition to your classical parameters like viscosity and water contamination, I promise you, your oil analysis program will be of very high value, independent from the application. And I will come back on that. And a graph that I always like to use for my good friend Rudiger at Ulcheck, and it's the graph here showing why it's so important to understand lube oil degradation in a proactive way. If you are able to monitor antioxidants and be in this induction phase, which is the red part of the graph, you're going to be much more in advance of critical increase of parameters like acidity or free radicals of peroxides, and come to the saturation phase with the formation of sludge and varnish, which we have spoken about. So understanding in what phase of this oxidation time and lube oil degradation cycle is so important. MPC, LSV will be contributing significantly to that. And therefore, a matrix that I always like to use when I'm a part of consulting projects or condition monitoring programs optimization is that I like to divide a matrix of oil analysis in three parts: soft contaminants, understand MPC amount, isoparticle counting, gravimetric test, also the weight. Think about hydraulic oils. The gravimetric patch test is so important. Fluid degradation with AO, health, infrared, and compatibility with contaminants. I cannot insist enough on looking at your air release as a foam, water demossability, who can be really affected by unwanted contamination, especially when there's a lack of flushing. OEMs and standard test bodies have also worked very hard and changed and optimized their condition monitoring methods, and not just for just for turbine oils or compressor oils, but also for hydraulic greases. I give here a few examples of some major OEMs today on the market. Also, standard test bodies like ASTM, DIN, VGB, where methods like MPC and voltammetry, LSV are clearly included and part of practices, just like, for example, ASTM D6244 or 4378 as very well known methods. I have just a few more minutes left talking about applications for AO and MPC testing. I would say as long as you have the fluid with containing antioxidants, think about aerospace greases. You saw yesterday a great presentation from Rich Woodsbach on LRVS on grease monitoring. Obviously, I don't have to mention this. Turbine oils, trending of antioxidants is of great value today. Look at this compressor oil program where you can see the red line with the depletion trend of antioxidants together with MPC. By doing this, you have a much better control of your operating conditions of your equipment of this critical compressor oil and optimize reliability. I spoke you about hydraulic oils as one of the emerging markets today, showing valve sticking or pump failure, as you can see here, and I must admit, the equipment with lower oil volume and high operating temperatures has, of course, accelerated issues like deposits and varnish. Um, where again, for some of you, it may not be that new, but I want to repeat that an LSV is a very effective tool also for monitoring the antioxidants capacity of zinc dithiophosphate, as we can see here in a mixture with amines or in pure amines or pure ZDP. The LSV technology can be of very high value. I have a nice case study here from my Chinese colleague, where we see this hydraulic oil with a good remaining amount of aminic antioxidants. Phenols are gone, but with an MPC of 64. Not have to explain you that this is, I see, an alarming situation. And for hydraulic oils, I would also recommend that you start including this technology. Paper mill oils, diesel engine oils, with a wide range of antioxidants depletion trend. Biogas engine oils, also an emerging market with more need for monitoring the antioxidants level rather than looking just at increase of acid number or decrease of base number. Um, uh, and then I think, last but not least, synthetic fluids like ester fluids on jet engine oils. A nice combination of this helicopter bearing, roller bearing behavior with the production of MPC values, phosphodester fluids, fire-resistant fluids. Also here a good combination and also very proactive value with these expensive fluids and where you can extend the lifetime and maximize the fluids lifetime because with ester fluids like phosphodesters, you produce these phenolic hydrolysis products, which MPC will then also start to increase as a result of oxidation of these free phenols. Brings me to my conclusions that you've understood that antioxidants monitoring is a critical tool for any lubricant that you use in thermally stressful environments. The combination with MPC is of very high value. And not to finalize that, AO monitoring can be of very high value for quality control, root cause analysis. And I thank you for your time and attention. Wish you a nice LRVS. I will have to jump now to my next session to moderate. And thank you for your attention.